Hi, everyone. Thanks for jumping on today. We're going to just wait one moment for everyone to get into our Zoom session, and then we'll kick it off. Looks like we have a good amount of people joining us live. We're really excited for the session. We're just going to give a few more moments for everyone to jump in. Okay, it looks like we have a good amount of people in. So here we go. Hi, everyone. My name is Courtney Brown, and I'm a Senior Marketing Manager here at EDB. I'm going to be your host today for our webinar, Cloud and Databases 101, Value, Sizing, and Best Practices. I'm joined by Tom Rieger, Senior Client Engineer at EDB. Before I turn it over, I'm going to go through a few housekeeping items. This presentation is being recorded. We'll be sharing the recording along with the slides after the broadcast to the email address you used to register for the session. All of your lines are currently muted. If you have a question, please feel free to submit it in the question panel within the platform. We expect the presentation to last most of the time today, but we'll allot any extra time to look at your questions. If we don't have a chance to answer all of your questions, we will follow up afterwards with you personally. So now I'm going to hand it over to Tom.
Great, thank you. And again, my name is Tom Rieger, and I'm here in the middle of the country where hopefully it is just as lovely where you are as it is for me. So let's go ahead and get started. So firstly, I want to say thank you. As I am a data person and I'm very data driven, I was looking to see all the people who are coming to the webinar today. And amongst everyone who is on the webinar today, there are 77 countries represented. And to talk about this idea of cloud and databases, specifically, we're going to get into Postgres. So I wanted to say thank you from me to you because that really speaks to the importance of the topic. And I think what people are looking to learn today, because I have a lot of exciting things to share. So firstly, we will be doing polling today. And I like the idea of starting with just a simple poll to get everyone comfortable with the mechanics of polling. So I am curious for everyone on the session today, what is your favorite season? Now, mind you, I'm here in Minnesota. Minnesota, winter is not what we answer in Minnesota because it gets to -30, -40 Celsius here. It is springtime. We're big spring people here, and summertime is awesome because we measure with a stopwatch. It's this narrow time in the United States where summer is great for me. And if you don't have an opinion because you live where maybe your seasons aren't changing much, first of all, you're always welcome to visit me where winter is if you've never seen snow. But we'll go ahead and let the poll run for about 5 more seconds. And then one of the nice things I like about the polling tool is when it's done, we will share back with everyone what everyone's favorite season was. See, that's how this polling is going to work. So Courtney, it's up to you. When do you want to click it and share it? Excellent. Well, first of all, I could tell people kind of like those more temperate seasons of spring and fall, but I do appreciate you taking this moment to understand how polling will work today for everyone. So let's continue. So the agenda today, we're going to talk about the cloud just a little bit, because I think we all appreciate on this particular August 7th date in 2021, or if it's August 8th for you now, because it's tomorrow, what the cloud is. And also get into this idea of really up to now, how we've historically sized data processing systems, the workloads. And I want to kind of get into a methodology we put into place here, where we took this methodology, we applied it towards a lot of moments to capture data. We then took the data and analyzed the data. And now today we're going to start presenting some of the results. So it should be very insightful. And I'm really excited for the topic. Let's talk about the cloud as a whole. The cloud is not new. The cloud has been around a long time. In fact, I would bet anybody who does webcasting, has their websites running, even their email systems, those have all been in the cloud for a long time. But then as you kind of progress into those more corporate systems, especially those distributed with all these people all over the place, like Salesforce.com or CRM systems, or your HR systems where you have resumes coming in, a lot of communications going out. You have a lot of distributed people, whether it's distributed geographically or distributed with a mobile device. That is where we've evolved to. And then over the last, I think, 5 or so years, people have started trusting the cloud enough to move, let's call it those second tier workloads into the cloud, where maybe integration wasn't as important. And yes, security was there, but they weren't really putting their tier one systems into the cloud until now. The critical workloads are what are next. That is when people start to really reduce the number of cubic inches of data center space that they have to air condition and manage, and they're trying to get out of the data center business and turn computing into a utility. So one of the things, though, is once we move into the cloud, if I look at kind of the three primary players of clouds, they've kind of made databases instantly confusing and a bit of a lock-in. If we look at AWS, we look at Azure, and we look at Google, they offer a lot of different database offerings on purpose. And once you kind of get in and use their database offerings, it's kind of hard to get off their database offerings. For instance, one of the things we found is you can have $0 for ingress to put things in, but for egress to get it out costs money. So they're going to start making it expensive for you to take things back out of systems. So I am curious, coming into this webinar for everyone, do you feel there is a degree of confusion in the database offerings from cloud vendors? Yes, it's very confusing. There's a lot out there. We're not sure about versions. We're not sure if they're secure. They're somewhat confusing. Yes, they say the words maybe SQL Server or Postgres or MySQL on them, and I kind of get what that is. I'm relatively, not very clear, or you're not sure. So I wanted to kind of get a take from everyone where you think you're at in terms of understanding what's going on in the marketplace. So we'll give this about 5 more seconds. All right. Thank you, everyone. Let's go ahead and share the results, Courtney. I think that everyone coming to this webinar somewhat feels like what I felt like when I first started really diving into what the 3 primary players were offering. It was somewhat or very confusing to most everyone on the webinar today, and I know it was to me until I really started diving into it. So that being said, let's continue the journey together. All right. So what is one of the ways to try to take the veil off of that which is going on in the cloud? Well, one of the things that we've done here in EDB as the largest purveyors of Postgres to you, as a focused vendor in this world, is we wanted to understand from a workload perspective, how do we measure? What do we start with from a measuring perspective? Well, workloads in databases have been around a long time. You've got traditional transactional workloads and analytical workloads, especially for those of you who are Postgres veterans. You have PG Bench is the TPC-B kind of clone. You also have analytical workloads. The TPC-H is a known one out there in the marketplace. And you get database-specific types of workloads. And whether it's Oracle tools for Oracle or SQL Server on top of SQL, or I mentioned PG Bench, or you get into vendor workloads. But all the while, there was a lot going on in this database workload world since the 90s that turned into aggressive marketing activities. And the TPCC benchmarks were ominous. For those of you who were around in the 90s, I worked at Informix in the 90s, and I have vivid memories of these billboards on the highway as you drove by Oracle's headquarters on the way to the airport, saying things like, we just raised the speed limit, or you just passed Oracle, so did we. But what happens is with a lot of these workloads that we see today is you see that the benchmarking, the sizing efforts going on today in databases is what I call performance at all costs. It's about performance, not economics. And what happens is it turns into, if you haven't seen the movie, I highly recommend it, Ford versus Ferrari. It's a phenomenal story about Henry Ford Jr. back in the late 50s, wanting to beat Enzo Ferrari at Le Mans. And he wrote an open check to Shelby, Don Shelby in Texas, to build a car to win at Le Mans. And that is almost like how we benchmark today. If you go look at all the benchmarks in the world, they are really like Ford versus Ferrari. And what we wanted to get into today and going forward with you is to have it be more of an economic conversation. It isn't about the GT40 going around the track at all costs, burning as much gas as possible with an unlimited budget. It's How do I take the least expensive car and use as little bit of gas as possible to get around the track as quickly as possible? Because we all have workloads. Our workload doesn't require going 220 miles an hour, over 300 kilometers an hour. And also leading into this, we have had in IT sizing this tailored suit philosophy. Well, how many cores do I need for something? How much memory do I need? What is my network bandwidth to make all of this work properly? And there's this combination of educated guesses and release notes analysis. And even today, as we work with clients, they ask questions like, well, how many cores do I need? How many cores do I need? And that decides both technical sizing and cost. But what happens with this tailored suit philosophy in provisioning things, whether it's on-premise or in the cloud, is if you, I call it lose or gain 5 pounds or 5 kilos, it doesn't fit anymore. Or technically, what happens if you under provision and you have to go back into your company and ask for more money? That doesn't go over well. Or just as importantly, what if you over provision and suddenly you realize that your ROI is not realized? You didn't get what you wanted out of it. It may perform great, but it was more expensive than you thought. That's not good either. So we wanted to take, instead of going to, and for those of you on the call from the United Kingdom, or, it's like almost a dream of mine is to think that I can go to Savile Row in England and get a custom suit made. Instead of getting a custom suit, I'm looking to go to the shopping mall or to a store like the Gap here in the US, and I just want a t-shirt. It's COVID times, I'm just going to get a t-shirt. And the t-shirt allows me to have this elastic sizing methodology. Maybe not all t-shirts are the same. Maybe if I go to one store in the mall to get a t-shirt that's extra large, and I go to another mall store and get an extra large, they're not the same extra large. And the clouds actually operate that way, by the way. So we wanted to take this elastic t-shirt sizing mindset, because also what the cloud gives us, supposedly, is this easy way to scale up or scale down. In terms of, if I need more, it's there for the taking. If I need less, it's there for me to give it back. So we're going to talk about things in a t-shirt sizing mindset for the next 30 minutes. But in this case, instead of the shopping mall and a t-shirt, it's going to be looking at them based on a small, medium, large, and extra large workload, and using some fundamentals around 2 primary variables, compute and RAM, and having everything else be as constant as possible in this laboratory experiment here. Whether it's the same amount of storage, the network, and also, since we'll be using a constant workload, the database size, concurrency, and workload will be the same. So we're going to convert this into t-shirt sizes we use in the cloud. There's also another reason for this particular ratio set, is because this is what we also find that the cloud vendors are using in their their lock-in database offerings, is around these same ratios. 8 gigs of RAM for every CPU core. So the effort at hand. The effort at hand is optimization. It is me trying to get around that Le Mans track in as inexpensive a car, using as little gas based on what I need to have in that car to get around the track as possible. And let's not forget, especially in IT computing, no matter what, no matter where you are in the world of the 77 countries, there's 4 fundamental things: CPU, RAM, storage, and network, fundamentally. And I can tell you from my experiences, especially in the cloud, each one of these have little moments where if you want more, it costs you more. As my mother said to me at a young age, son, nothing is free. And what the cloud has proven to me is nothing is free. At the same time, there are things they will act like they're giving you that you never really realize, using words like up to and maximum. So we're going to use a defensible workload to sit over the top of what we're doing and showing today. And what we want to make sure we do is to, coming out the other side of this, is to come up with all the different tools to help you understand what good looks like and how to use the cloud in data processing. Whether it's how you technically provision it, how you choose the Lego pieces of the cloud, whether it's CPU, RAM, storage, and network, and put them together the right way and optimally. But most importantly, to come up with that business case assessment template to help you understand, here's a way for me to not think about every time I provision something, it's like a custom suit. You get to start from an educated guess, because all of us, when we go into a mall, have an educated guess of what size t-shirt we wear. And here's an example of the confusion. Let's start with the confusion. Let's start with the fundamentals of using the cloud for data processing. Fundamentally, number one, let's use Amazon as the example. And by the way, the other two clouds are almost just as guilty. In fact, Azure's more guilty of this. This is a table looking at all the different 8 CPU virtual machines offered by Amazon. There are 44 choices, ladies and gentlemen. 44 choices with a mix of what's the CPU model and speed and age and how much RAM and the bandwidth and the, on and on and on. But most importantly, amongst those 8 CPUs, which one's the right one to use for a database workload? Also, let's consider the economics, because again, I'm not here looking to get around that track like Henry Ford Jr. wanted to in Ford versus Ferrari. I'm wanting to make this as inexpensive as possible. And the economics, and my apologies for the use of US dollars, I'm sure if I could, convert the table for you, but it's, as cheap as $93 a month or as expensive as $1,500 a month to use an 8-core environment inside Amazon. So what does good look like? That's compute. Let's talk about storage. So in what we're going to be sharing today in terms of numbers, we used a 600 gig database, a provisioned 600 gigs of disk space. And across each of the 3 clouds, you get a different set of choices in what you can use across the 3 clouds. So in Google, you have 3 choices: standard, balanced, and SSD. And also I italicized the lettering because if they're italicized, I can't control that variable. I cannot control whether it's the input outputs per second or the throughput. And the reason I'm sharing this with you right now is you'll see where this converts into technical limitations or technical capacities, but it very quickly turns into economics. So in Google, I have 3 choices ranging from standard disk to SSD. Now, this entire exercise in my organization started with Tom Rieger, me being asked, hey, if you're a DBA moving to the cloud, help me understand what good looks like. Well, if I'm going to go move a tier 1 workload to the cloud, I'm going to go get the faster disk. It's just natural because in disk speeds, you're dealing with IOPS and throughputs that are measured in megabytes per second, where at least with CPU and RAM, you're measuring with things like the speed of light in nanoseconds. In AWS, you have a lot of choices. In fact, they make it quite interesting because they don't just have IO1 storage, they have IO2 storage. And the biggest difference there is really around its uptime. IO2 storage has 5 nines of uptime. And then finally in Azure, what was interesting about Azure is you could only provision it based on what I call binary pricing. If I want, a few gig, or if I want 600 gigs, I have to go and provision a terabyte. So the assumption I had to make there was a terabyte of disk. And also, and I'll show you on the screen here shortly, performance limitations by VMs. In fact, each of them all had limits on how much the compute could handle from an IO perspective. But look at the broad set of storage offerings and performance characteristics. And also, I put in uppercase on purpose the word max. So do I ever realize the max? Do I ever exceed the max? Well, not really. When you get these slides, I wanted to make sure you saw in yellow the different links in which I extrapolated all of this information, and I will be doing that throughout the presentation for you. So you can go back and refer to, let's call it the PowerPoint bibliography of that which is going on in this exercise. What's our workload? So we chose as our workload HammerDB, and there's a lot of reasons why. One, it's evolving open source community-driven tool that gets better over time all the time. It is not static, and it is there available to you on both Windows and Linux. Secondarily, it allows you to have still a standards-based workload based on the TPCC for transactional workloads. And something we're looking to do here within EDB shortly is to turn on its analytical workload capabilities and measure how it does there. And it also works across databases. So it isn't just for Postgres. You can do this across other enterprise databases that you use today, whether it's Oracle, SQL Server, DB2, MySQL, Redis. They have all kinds of other ones they support. So it then gives you this one measuring tape to go and measure multiple projects to get an idea of what good looks like from a tooling perspective. Also, it is a standard workload. So no matter if I use it across any of the clouds, as long as I use it consistently, it will give me ability to start to come back with apples to apples compares. The anatomy of the benchmark is illustrated here. It is a transaction processing workload for a warehouse. A warehouse has a number of warehouses. It has a number of customers. It has orders. It has new orders. It has history. You're picking stock. It's doing that kind of fulfilling thing in a warehouse. And the way it scales up, the two primary knobs is database size. How many warehouses do I have? For our workload, for what I'm going to share today, is we decided to set that at 600 warehouses, which is equal to 120 gigs of database size. And also you could set up concurrency. So you have kind of an X and Y coordinate there. Most importantly, you get one fundamental measure out the other side: transactions per minute, TPM. You will hear me use that acronym a few times over the next 20 or so minutes. It's worth noting too that the mix of what happens in the TPCC kit is about 75% queries, reads, and about 25% writes, inserts, updates, and deletes. So there's a lot that went in there to optimally size what's going on. And as I mentioned previously, there were two dimensions. There is the database size and there is the concurrency. And we decided to focus on, because again, I've got 4 t-shirt sizes. Everything as small as 4 CPUs or as big as 32. How do I actually test and compare across such a broad set of machine sizes? We found that optimally, it was about 120 gigs and 96 concurrent sessions, because I'm a binary guy and 96 is a lovely binary number. Then, once we figure out the workload, and as I previously shared with you the idea of the different machine types I had to choose from, like in Amazon, there's 44 8-core environments to choose from, and which storage do I choose, and where does it work? That was the next thing we discussed. A quick observation too, as we go into this, there were a lot of lessons learned that we went through. We want to make sure that we share with you moments where we failed so you succeed. And this isn't a failure comment as much as it is an observation. It's not all clouds offer the same compute, because I'm going to be sharing some numbers with you here in a couple of slides. And I want to make sure that everyone realizes that in AWS, I got 3.2 gigahertz Intel processors. All the way down to in Azure, I got 2.6. So there was this, how do I optimize what I'm doing from a CPU, RAM, network, and storage perspective to get the best throughput, the best, dollar sign, euro sign, currency sign for you at the other side. How to best tune the database. So we've talked about the silicon, the memory, the storage, the components of the machine. Now within Postgres, how do we properly configure Postgres? There was a lot of learnings here too, and a lot of people involved. And also, how does that map to the use of each cloud? So for instance, we decided to separate the logs from the data and indexes. And how do we properly set up the disk volumes so that we optimize that? Monitoring and measuring was done through a lot of, and we wanted to compare and contrast the different tools across the clouds for monitoring and measuring that were above and beyond what we could do ourselves with command line interfaces. And as I mentioned, there were a lot of both moments of successes and moments to learn to get to the bottom of what does it look like. Within our company, within EDB, we went through with our CTO friends an internal, what I call, set of mock trials and validation points. Could this be replicated? Is this available for you to do yourself? And what numbers that we came up with, you would see as well. So there's a lot of internal validation. I don't want to say the word audit. That's an ugly term in English, but there's a lot of mock trials. Mock trials is a term from law school in the US, where you get in front of the professor in class and you actually go through a trial like a court of law. We went through a bit of mock trialing here within the organization. Finally, we engaged different customers to get their input around what we're doing here across this methodology I just described. Taking HammerDB, running transaction workloads over the 3 clouds, using Postgres to get to the bottom of what are things that are learned, both technically and financially. So I wanted to share some visuals of some of the people in our organization. These are some of the same people who do webinars from EDB all the time, who are major contributors into the Postgres community, and who represent a combination of both my team on the customer engineering side or sales engineering side, along with performance engineering, the CTO office, and of course, the customers I had mentioned. So let's talk about the dimensions of the effort. So as I mentioned, we have HammerDB. We use 3.3, 4.0 is out now, but we use 3.3 because we started this effort back in November before that came out. and we used a four-way processor in the cloud. It was a separate machine from the database because the HammerDB effort itself can be quite CPU intensive, and we didn't want to starve the database. We ran over 360 separate benchmark runs across the three clouds. We generated, in fact, over some efforts I've done last few days, we're now over 33.6 terabytes of data and indexes were generated across those 360 instances. And we evaluated different storage options, different Postgres configurations, and a whole lot of different elements as part of this. So I wanted to just share too that across all these different benchmark runs, there was a combination of concurrencies, database sizes, compute and RAM, and cloud options that were given. So let's get into the results. The results, first of all, we're taking the 4 t-shirt sizes: small, medium, large, and extra large. I do want to highlight, we focused on 120 gig database, 96 concurrent threads. So when I say threads, that means that each connection to the database hammered the workload with transactions. We used the latest Postgres. We did the runs for 30 minutes, and we made sure that the pricing was apples to apples so that everything you see here that I'll show you economically is the same. And we also used the best efforts EDB Postgres tuning. So we use the same tuning parameters across all the clouds. So we have performance, transactions per minute, small workload. Here's what we saw across Google, AWS, and Azure for transactions per minute within that 4 CPU and 32 gigs of RAM environment. Now, I mentioned too how the CPUs weren't exactly the same, which may make up for some of the deltas that you see here. But where this becomes very important to realize, this isn't Ford versus Ferrari. This is how can I get around the track the best? It is about price performance. So once I take the performance and divide into it the dollars, the money, you can see here very quickly that Azure becomes more expensive in these small t-shirt sizes, and Google and AWS about neck and neck. Now, let's continue the journey and grow this. In our medium t-shirt size, we're starting to look a lot more alike. We're plus or minus, I don't know, 10%. But we also see where the pricing starts to get more in line. Let's go to the large, 16 CPUs. Now we're starting to scale even further out. We're starting to get well north of 10,000 transactions a second in these 16 CPUs on Azure, but really across all three. What does this really do to the pricing though? They start to become even more alike in terms of pricing. Finally, 32 CPUs. Now we're hitting 20,000 transactions a second, almost 1.2 million transactions a minute. And when we translate that into the cost to make that happen, now we're almost, the horses are nose and nose across the finish line in terms of cost. Now, what we look to do and share with all of you on this webinar, whether you're watching it live or recorded, is how we got there, and also to bring you best practices. But we wanted to share with you what we saw in taking Postgres, loading it on each of the clouds in each of the t-shirt sizes, and coming up with a best effort number out the other side. But be prepared for a few things. So I do want to call out lessons learned. This is cloud and databases. And again, the title spoke for itself. This is about value, and this is about finding what is the right way to get that car around that Le Mans track. First of all, let's talk about the Google Cloud. There's no way to control the disk performance. In fact, the only way you control disk is by provisioning more gigabytes of it. That's the only way you could do it. It does give you the cheapest disk for the performance, but they didn't really have any top tier storage like the other two. The other two like to talk about IOPS and megabytes per second throughput and come up with these equations that are complicated. Google was just like, you provision this many gigs, you get this kind of performance. And again, I'm reinforcing, you get up to those numbers. They also had the smallest number of choices when it came to virtual machines in terms of compute and RAM. But I was impressed, I have to say, from a Google perspective, that they were most proactive in showing me how I can save money. Maybe they saw that I wasn't using the compute effectively and they say, hey, you could do more with less. Let's talk about Amazon. Their storage can get expensive really fast. In fact, if you use their IO1 or IO2 storage, you do this thing called pre-reserved IOPS, input outputs per second. And I'm still waiting for somebody to tell me what an IOP is consistently across all the clouds, because they all talk about them like they either invented them or they set the standard. But is an IOP an IOP? I'm still not really sure. So, but the real question, especially when it comes to IOPS, is how many do you need? And most importantly, especially with Amazon and Azure, is they don't really tell you what you need. You just go turn some on, and then you think you're adding more to get more out the other side. I do want to mention too that the VMs that we chose, the virtual machines, the Intel and RAM combinations in Azure, or I'm sorry, in Amazon, were the same that are used by RDS and Aurora on purpose, and I'll share with you more shortly. They do offer non-volatile memory as a storage option inside Azure, but it doesn't persist. If you bounce the environment, you lose what's on that NVMe storage. For those of you who don't know NVMe, it is really, really fast, like on motherboard storage that highly accelerates the communication between the RAM and the disk and highly accelerates how quickly it reads and writes to the chips themselves. But if I bounce the environment and I lose what's on there, what's the point? Finally, all the clouds somewhat, dare I say, obfuscate what they do around their configuration settings, but Azure was the one that actually made it a little harder than others. Once you figure it out, it kind of makes sense. Azure, their storage, they have this thing called UltraDisk. UltraDisk is ultra expensive. That should be like my bumper sticker on my car. And they also make the math confusing on what you pay for. And you're never really quite sure what good looks like in terms of your disk provisioning with UltraDisk. We also ran into some problems with provisioning. Certain regions in the world didn't have enough of something. We get this convoluted error back. Or you need to make sure you understand what they call resource quotas inside Azure. For instance, with my CPU environment that I use, I had to go and request tech support to give me more quota of something before I could turn it on. And you're really not sure why or what that means until you kind of go through this exercise. And I'm willing to share with all of you what that means. When it comes to their DBaaS offerings, the Azure DBaaS offerings, you have the least control of your Postgres. And also they use the oldest Broadwell processor, the Model 51 from Intel, which is 6 years old architecture, the slowest disk and the oldest Postgres. If you go use Azure Postgres, they're on still 11.6. And all of them had fundamental monitoring, very mom and apple pie. Here's what's going on with your CPU. Here's what's going on with your disk and your RAM. But when it came by way of the database and monitoring and actually proactively sharing with you back what's going on with the database, you were down in the call-level interfaces doing a lot of PSQL commands and figuring out yourself. So all of them, from a monitoring perspective, kind of had some of those same challenges from a database administrator perspective. Now let's talk about storage in the cloud. This is where it gets interesting. And I want to give you this example with UltraDisk. So UltraDisk, as I mentioned earlier, you provision it in a binary basis. You don't get to choose exactly how many gigabytes you want. You've got to provision it and pay for it based on 256, 512, a terabyte, and so on. So in my environment, if I'm going to have a 300 gig log for a wall log volume and a 300 gig for data and indexes, I actually have to provision two 512 gig volumes. So I'm paying more for that. Also, you need to configure IOPS and throughput. And also, each VM kind of has their limits in what you can do with UltraDisk, but it's a little convoluted. Now, the pricing, for those of you who appreciate the movie Good Will Hunting, it reminds me of Matt Damon being at the chalkboard solving the theorem at MIT to figure out something. You start to do some of that same math to understand how all of these moments of 15 cents per month per gig, 6 cents per month per IOP, or $1.23 per month for megabytes per second, what that translates into. And I mentioned how VMs publish limits. Well, they don't publish limits for UltraDisk. They publish limits for what they call max uncached disk throughput. So within these compute environments I used, here were the maxes that I will ever realize. Please note, no guarantees, just maxes. Now, let's start doing some interesting economic math here. So storage in the cloud using UltraDisk. On the left-hand side, I call out how this is the medium t-shirt size and all the other variables that nothing changed. But what did change and what I'm about to show you, the only thing that was different was the IOP disk performance and the megabyte throughput for the disk. Now, at 35,002, basically 2 gigabytes per second, my storage cost is $9,000 a month. And I got 300,000 transactions a minute. I'm using round numbers. And if I look at the total cost for the environment, the compute, the storage, the Postgres, it's 42 cents a transaction. So this is where the dollars per transaction per minute becomes a very viable measure. We're trying to get to how cheap I can get around that track in Le Mans. Now, if I start to take back some of the performance and I detune the disk, I don't know if detune is a word, my apologies if English is your second language, but if I slow down the disk throughput and the disk performance, does anyone notice how my transactions per minute are barely affected, but yet my economics were greatly affected? What my disk cost went to was from over $9,000 a month for disk down to about $1,000 a month. And the total cost of operations for this environment dropped by 4x, by over 400%. No other variables changed except disk performance. Observation number one. Observation number two, I don't want to say that AWS is innocent in this as well. I mentioned how their disk is expensive. And in this case, we took their IO2 disk and we detuned it. The only variable it allows you to tune are your IOPS. And as you drop your IOPS from 35,000 down to 3,000, you could see here very quickly that my transactions per minute were barely affected. But what was affected was how much I'm paying AWS for that storage. It dropped from almost $2,300 a month for the storage down to $270 a month. Now, you do get to a point of diminishing return. Again, dollars per transaction per minute. Once I look at the total cost of the operations, once I get to 3,500 transaction IOPS on the disk, I then start to starve it, and now my total cost of operations start to go up below that 3,500. So now I start to get to a point of diminishing return. So we want to make sure that we share with you these moments when it comes to storage and what does good look like, especially when it comes to not just the performance characteristics, but what it starts to cost. Polling question. I would love to know, everyone on the webinar today, would you be interested to have these kinds of research efforts and findings done around these particular offerings? And please answer all that you are most interested in. This is not just a pick one radio button and submit. Click all that are interesting to you, because I want to make sure that what we're doing here to measure the cloud is as relevant to you as possible. Because if we are going to be these primary purveyors of Postgres to you and really be this leader in databases, we want to make sure that what we are giving you as both attendees to our webinar, and if you're a customer of EDB, is of highest value. So what would you like to see? Let me know. Because what I want to do is to take the same level of granular research, both from an experience and time study perspective, from a technical perspective, and most importantly, from an economics perspective, and share that back with you. All right, Courtney, I think we're there. So this is very intriguing to me, that actually Google was as high as they were, so nothing against anybody on Google on the phone, but I've had a lot of asks for this. And I thought I want to share with you that this is something that isn't just on our radar. So Courtney, you can close the poll. Thank you. Excellent. We are doing it. In fact, in a lot of cases, we have done it because we want to help you decide what is optimal. So we took the HammerDB workload, the TPCC workload. Again, consistent effort over the top of the database, consistent scale and concurrency. And we took not just what we did in red, because what we did and what I showed to you is the stuff in red, where we took a virtual machine, had Postgres on it, and we did the workload over it. But we have also already done most of what we have over AWS, over Azure, and over Google. And I definitely want to make sure that we share this the right way with folks. So if this is intriguing to you, if this is interesting, tell me in the Q&A. I want to know in the Q&A, both based on the polling question that was asked, but also if there's something that wasn't in that polling question that you would like to see challenged or checked out, what makes sense? Because we want to help you choose the right car for the job. It's all about cost of ownership. It's about workload. You don't need the big American SUV to tow a little boat. What is the right tool for the job? So, that being said, let's continue. Deliverables to you. We want to make this more predictable and prescriptive for you. We would like to think in this time of cloud and t-shirt sizes, and you think about which departments, which store you go into to buy your t-shirt, and you're striving for elasticity, what does good look like? So we want to come up with how-to documentation and also reproducible scripts. Someone within our CTO office is actually creating scripts to make it easy for people like yourself, for anywhere in the world, to take those scripts, run them against a particular cloud, and to, if anything, reinforce the math and some of the measures and some of the best practices that I just shared with you today. Again, maximizing value and best practices, cloud and database. Also, best practices around cloud setup and database configuration. If you go and choose the wrong virtual machine or choose the wrong disk and you tune Postgres right, did you accomplish what you should have accomplished? The answer is probably no. If you chose across those 8 CPU environments I showed you on Amazon, if you choose that super expensive one and you tune Postgres right, your cost per transaction is still going to be bloated. Time studies. So for instance, time studies and how long does it take to run the benchmark? How long did it take to run vacuum full in the benchmark kit? How long did it take to do things? We want to make sure that you have a degree of formulation there in terms of the value of your time around this effort as well. And finally, what are those right business documents and those right formulas? And as I like to put it, we here on this webinar generally thinks in bits and bytes, but yet the people who pay for things thinks in debits and credits. And how do we translate transactions per minute and all this technical stuff into dollar per transaction per minute to get you the right fuel economy out of that cloud environment? Polling question. I do want to know though, these are things that we've been thinking about within the organization that we want to come up with for you. Would you find this useful? Yes, very much. I think so. Not really, or you're not sure. I want to make sure that everyone on the webinar today has a voice into this effort because this is something happening right now. Again, there are 4 primary pillars of activities: deciding the workload, gathering the data, analyzing the data, publishing the results. We're in the middle of all of that right now. And I want to make sure that using a forum like this gives you a voice in what you see in this effort. So we'll give this about 5 more seconds, Courtney. All right. Thanks, everybody. So I appreciate your reinforcement of what we're looking to come up with here for materials and collateral, because that is exactly what we're looking to accomplish. Because we want to make sure that if you are moving your workloads to the cloud, you choose the right cloud for the right workload. Again, this is which t-shirt fits you best in the store. Well, it's not always consistent. So let's kind of close things out here. Key takeaways. There are some key takeaways here that I want to make sure that you take from what we have done in terms of heavy lifting and lessons learned and what we shared with you today and what we're looking to share with you. It's difficult to technically compare cloud database offerings. It is, even as we've looked at the other DBaaS offerings. But once you put a performance number under an economic number, what is your cost per transaction ends up being the most important measure. Secondly, most enterprises over-provision and overpay for Postgres in the cloud. And I would say the example is true when you think about the storage example I gave you between the IO2 disks in AWS and the Ultra disks in Azure. It's very, very easy to over-provision and very quickly overpay for what you're doing in the cloud. Third, some cloud offerings restrict your flexibility to tune. There is a lot you cannot do across the DBaaS offerings today, across the 3 primary clouds that I've described. And also, once you provisioned up, you actually can't provision back. For instance, if you go and provision a certain amount of compute or storage inside Azure's flexible server, you can't give it back. So you're only going to scale up, never back. You have certain kind of older hardware or older releases of Postgres across all the DBaaS offerings, depending on which one we're talking about. And finally, we want to know more around specifics around what you are looking to do with the cloud, because we have a lot going on here at EDB and what we're going to be coming out with through the year. And we want to make sure that it fits into what you see and what you need. So there is more to come. So who's EDB real quick? So we are the, as I like to call it, the primary purveyors of Postgres, striving around making community Postgres the norm for everyone. We also have an advanced server of Postgres where we add in things like Oracle compatibility and other components into the kernel of Postgres. It's binarily compatible with community Postgres, but more importantly, we add a lot of the toolings around Postgres, that second box down, and they're in green down below. But it's really about how do you best monitor and keep operating your Postgres. You have 4 nines, 5 nines, you have hundreds of instances or thousands of instances. How do you make sure that from a database administration perspective, those are optimized and operating according to the service level agreements? From a support organization perspective, we're the largest support organization for Postgres in the world, 24/7 support, and we have what we call DBA services and technical account management. Finally, services, end-to-end, little moments of engagement to help you or longer services of engagements to help you. If it's something as mundane as moving off of one database onto another, migrating into the cloud, coming up with a strategy in what you want to do, that's what we bring to bear for you as the largest purveyors of Postgres in the world. Postgres Vision 2021 is coming up June 22nd and 23rd. Or for those of you outside of the side of the United States, the 22nd, 23rd of June. You put the date in front of the month. Please make sure you go out to postgresvision.com. The call for papers is open right now. And I'm very excited personally to see what is happening during this session. It is going to be a global event over 2 days. It is a digital event. And I wanted to make sure that all of you were both informed of it and registered today. In closing, first of all, if you have any questions at all, please put them into the Q&A session. Not just questions, comments, wants, needs, desires, anything you need, please put them in the question area. Because what I want to do is, because we're getting near the top of the hour and based on the 77 countries who came to this webinar, it's a little late for a lot of folks. I want to thoughtfully answer all of those questions, especially there is a lot more data. We've ran over 33 terabytes worth of data and indexes across over 260 benchmark runs across all these clouds. There's a lot of things that I can pick and pull out of there for you based on your questions. So please put your questions, comments, wants, and needs in the Q&A session. There will be an exit survey that pops up, that comes up. Please, please, please answer it. That helps me understand how well this went today for you. Finally, if you have any questions for me, here's my contact information. Here's my phone number. Please don't hesitate to reach out to me on LinkedIn. There's not that many Tom Riegers out there, especially in Minnesota, in the United States. So I want to make sure that if you have any questions relating to what good looks like in the cloud for databases, and to really dive into this value and best practices that we want to bring to organizations, that you have a voice and you have a say. So that being said, I want to thank everyone and have a great day. Over to you, Courtney.
Great. Thank you so much, Tom. So we'll go through and see if we can maybe answer just a couple questions. Otherwise, it looks like a lot have come through. So we will definitely follow up on the ones that we can't answer. A few people asked if this was being recorded. The answer is yes. We will be sending out a recording and a copy of the slides to the email that you used to register for the session later today. So we did get a few comments about other sort of research that they'd love to see. So of course, we'll look at that afterwards. Yep, exactly. PowerPoint slide will be shared via email. let's see what else came through in questions. Someone just wanted to clarify, were your performance metrics captured using open source Postgres or EDB Postgres?
Both. You run 360 benchmark kits, you have a chance to try both. And that's what we did. We found no more than 1% difference between EDB Postgres and Community Postgres when it came to applying what we applied to the configuration environments, how we set them up, and how we ran them. So there was, let's call it plus or minus 1%, which honestly, as there were moments in the cloud too that I ran the exact same benchmark over the exact same cloud more than once just to validate the numbers. And even if you run everything exactly the same back to back to back, you would get 4 or 5% differences. It's also worth noting too that every benchmark was ran on a fresh load of Postgres. There was no pre-warming up that went on. It was a fresh database load, an index build, and vacuum and analysis took place. So everything started from and I'll use my automobile analogy, the smell of a new car out of the showroom moment, right? There was not a lot of miles on anything. It was all very fresh on every run. Because I wanted to make sure that for everyone watching this, your questions appreciated the amount of effort we put into making this being as defensible as possible and as what we call apples to apples in the US in English, but as something that you could see where you could take this to your management and say, look what EDB did to give us an idea of what good looked like, and we could defend it unconditionally. So back to your EDB versus Postgres, 1% across the same cloud over the exact same things multiple times, I was getting 5% differences.
A few people had just general questions about running Postgres and Kubernetes.
Let's take that offline.
Okay.
Because that kind of gets into a whole nother level, because yes, you start getting into different challenges there. The moral of the story that we took here from a best practice across cloud is we were a slave to, across the 3 primary clouds, what they offered, along with, if we were looking to also look at the things like RDS and Aurora, or Google Postgres, or Azure single server, or flexible Postgres, we wanted to make sure that we were constant across all of those, and things like containerization took away from that consistency. But it's not like it's not on our radar, because we are very curious to see how well that scales, even compared to virtual machines.
Great. Yeah, there's a few people that are saying like, oh, we'd love to see benchmark of on-prem versus cloud. Some people would like to see
well
high availability.
That's a great question, Courtney. If you want to do on-prem benchmarking, I will gladly share with you what we did to do this in the cloud, and you can download HammerDB for free. Here are the scripts to run it yourself. Go to town. One of the big reasons we chose HammerDB as our kit is, again, it's free and it's an evolving tool available for download, and it's open to other databases. And the act of making it run is actually very straightforward. So I will gladly send anybody who wants them the scripts to do this themselves on-prem.
Okay, it looks like.
So I do want to answer one question here.
Okay.
Because it's a transactional workload and because of the size of the databases, we did not do any partitioning per se. We did try actually separating the indexes from the data in 2 different volumes, and we saw that making negligible differences in the performance. So we just kept them together, again, so that we had consistency across benchmarking across the clouds, and to also make it, the more we made it customized, the less it looked apples to apples and defensible. So we tried to minimize anything we did to make things look sketchy. Don't know if that translates. So that was something we did not do. But there's a lot of questions. So I want to take the questions as we're now near the top of the hour, and answer those for everyone. And I will make sure that for those of you who want certain things, I answer those here in the next day or 2 for you. So that, Courtney, let's call it a wrap.
Perfect. Thank you all for your time today. And Tom, thank you for such a great session. We got great feedback here. So thank you all. Recording and slides will be sent out and we'll follow up.
Oh, and take the exit survey. Please, please, please take the exit survey.
Okay. Thanks everyone. Have an awesome day.